How to build a model steam engine, Stuart Models Victoria, Part 9, Machining the Steam Cylinder. This video footage was originally used in my series Model Engineering for Beginners, and in this video I'm using the larger of my two lathes to turn the cylinder, which makes it much easier. But whichever lathe I use, the first operation is to make a mandrel that fits in the tailstock chuck, and this will allow for accurate positioning of the casting when I fit the four-jaw chuck. This is a half-inch capacity tailstock chuck, so I've turned the mandrel down to half-inch. With the half-inch part of the mandrel fitted in the lathe's three-jaw chuck ready for turning, I'm just checking that it's the right length to support the entire casting. If in the initial inspection of the casting you noticed any lumps or bumps down the core in the centre of the casting, you will need to remove these with a file so that the casting sits accurately on the mandrel. The next thing to do is to take a facing cut, a gentle facing cut, because the piece of work is protruding quite a long way from the chuck. And then, using a centre drill, make a deep centre impression in the end of the work. This will then allow use of a live centre. The live centre supports the work at the end furthest away from the chuck, so when you start to turn it, you'll be able to turn it without any chatter and without it wobbling about. When you get the mandrel down to the finished dimension, and do bear in mind that we do not want it to be a tight fit in the casting. The casting just needs to be a snug fit to hold it steady whilst it's fitted to the main four-jaw chuck. The sole purpose of making this simple mandrel is to ensure that the chord hole of the casting runs down the centre of the four-jaw chuck, so that when the boring process is completed, the bore follows the external shape of the casting. And when the engine is completed, everything looks right. You could still get it to work with it being slightly off-centre, but it wouldn't look too good when it was mounted on the bed plate. So, with the cylinder casting on the mandrel and the mandrel mounted in the tailstock chuck, move the casting into the jaws of the four-jaw chuck. But don't go mad and don't suddenly start tightening everything. Initially just move the jaws towards the casting, and then keep working your way around until the jaws just touch the casting. In my workshop I have two lathes. One is a Boxford, which is quite a small one, and one of them is an old Smart & Brown lathe, which is much bigger. So I'm using the Smart & Brown lathe to machine this casting, and the four-jaw chuck is much bigger than the one on the Boxford, but the same principles apply. At all times when machining, whether you're machining a piece of bar or a casting, make sure that the work is securely held in the chuck. If it works loose, the work will be totally destroyed and is likely to fly out of the chuck and hit you in the face, which is not a good thing. If you look at the shape of this casting, you will see that the port face is a nice flat surface to grab. The other side is not so good. You're only really grabbing the casting by the end part, so it's a good idea to use some packing. This is a piece of brass, and this allows you to clamp directly to the casting. Once again, make sure that everything is clamped up tight. If the piece of brass flies out of the chuck, that will also cause physical damage, and an afternoon in A&E is what we don't need. Once you finally get the casting in the perfect position, take a fine facing cut across the front of the work. The video that you've just been watching, showing the setting up, really was a setup. I did it very clumsily to show what happens if you're clumsy, and you will see that the tailstock chuck moves up and down if you get the casting off centre. It takes quite a while and you need plenty of patience, but finally it's time for the first cut, and the first cut needs to get under the skin of the casting, because you do need to get straight away under the shale and sand layer, otherwise you may blunt the tool. A quick word on the type of tools to use for boring cylinders. You can of course use high-speed steel, but high-speed steel will need sharpening frequently because it does blunt. Cast iron is a very strange metal. It's got a high carbon content and it's quite slippery, but impurities in the casting process tend to blunt the tool. Here I'm using the usual carbide tip tools, which are a lot better, and replaceable tips just make them very easy to use. I find that a nice steady speed, I'm not actually in back gear, on this lathe this is the slowest speed without using back gear, but it's a good speed. Don't go too fast, it's vital that you do not go too fast. If the spindle speed of your lathe is too fast, you will probably get chattering, which is a high frequency whining noise. And when you look at the work, you have a high frequency whining pattern in the work. Also, this will generally blunt the cutting tool and the finish will suffer. It's important to have a sharp cutting tool when boring a cylinder, that way you get a good finish. As I mentioned previously, there are many different ways to bore a cylinder. This is the way I do it and it seems to work for me. When you get close to the final dimension, which will require frequent checking with either a pair of calipers or a plug, it's a good idea to make the piston first and then use it as a plug gauge to make sure that the cylinder bore matches the piston. This is a 1-inch bore cylinder and I need the bore to be 1 inch. If it's larger, then I would have a problem, particularly if I was fitting cast iron piston rings that come in set sizes. Here is a top tip to get a good finish on a cylinder bore. After the cutting tool has gone all the way through the work, stop the lathe, reverse the feed so that the cutting tool starts to cut pulling it away from the chuck, and restart the lathe. This will remove any high points and you do get quite a good finish. And when you get to the outer end of the cylinder, which you originally faced with a facing tool, use the boring tool to reface the front of the cylinder. This way that does ensure that the cylinder bore and the end of the cylinder are at a perfect right angle to each other. If the end of the cylinder was not at a perfect 90 degrees to the bore, it would not be good at all. When you finish the cylinder and bolted on the cylinder cover, the piston would not go up and down in the cylinder. Not what you want with a steam engine. So here you can see the process underway. The boring tool is coming sideways towards the operator and facing the end of the cylinder. Again, I'm using a very slow feed and the same lathe speed. This way I'm getting a good finish all the way around and it's not putting a great deal of stress on the casting. And as this boring tool's not been moved and it's gone down the cylinder and it's now coming across the cylinder and the flange must be at a 90-degree angle to each other. To achieve a perfect 90-degree angle at the other end, you have a couple of choices. You could of course set it up in the 4-jaw chuck. You have a cylinder bore, so you could use a dial test indicator, etc, etc. But this takes time, and this is much quicker. I made a simple mandrel. The mandrel's diameter is 1 inch, which fits the bore perfectly, and at one end are 2 sliding collars and a couple of O-rings. So when you clamp them up, the O-rings grip the bore, and you can turn it in the lathe, and the whole assembly can be supported by the live centre at the other end, and it takes a very short time to get a perfect 90-degree angle at the other end of the cylinder. Yes, of course you have to make the mandrel, it's not a commercial item, but if you're going to make a few 1-inch cylinders in your lifetime, it comes in useful. I do have a few other mandrels like this that I've made for various cylinder jobs, and they do the trick ideally. It takes the chaos factor out of it for me. Setting the cylinder back up in the 4-jaw chuck with a dial test indicator seems to me to be like hard work and drives me nuts generally, apart from which, if the casting moves, all your work so far has gone, so you want to be very careful with that. Perfect engineering is a compromise in the home workshop for most people, myself included. I try and get it as accurate as possible, and it seems to work as most of my steam engines run without knocking or clattering or banging. If you watch some of my other videos, you'll see what I mean. Once this second end of the cylinder has been faced, it needs to be put back in the 4-jaw chuck to machine the port face. You must use some packings on the newly machined surface, otherwise the chuck jaws will make it look like this. I did this on purpose, this is not an accident, this was a scrap casting, so I quickly machined it to show what happens if you don't use packings. There are various ways to do this job as well. Some people will fasten it to a faceplate or a Keats angle plate or whatever. I don't have one of those, so I can't do that. I put it back in the 4-jaw chuck and first of all take a rough measure from each corner. And then I would use a set square against the lathe top slide to ensure that the casting is at 90 degrees to the lathe. That way, when I machine across the face, like you see here, everything's fine and you get a nice flat surface that's accurate. And as before, make sure that the first cut gets under the skin of the casting to avoid blunting the tool. The main machining operations are almost complete now. The last thing to do is to machine the port face for the exhaust outlet. I'm doing this in a milling machine. If you don't have a milling machine, you could use a milling attachment in the lathe, and if you don't have one of those, you could actually use a file for this. but practice filing, which is an art in itself, on some scrap metal first so you get it flat. During the course of this video, I've shown making mandrels, which is part of the tutorial process. And mandrels are very essential in a lot of jobs and make jobs very easy. Fittings and jigs are an integral part of model engineering, as they're an integral part of full-size engineering. And years ago, when I used to read about jigs and fittings, I used to glaze over a little bit. But once you work with them, you realise how important they are. And it's good experience of basic lathe work making simple mandrels. Make a selection, you'll find that they do come in useful. Well, that's just about it for machining a cylinder. Here I'm cleaning the outside of the casting with a needle file. You need to do this really, it's just the moulding flash from the moulding process that you need to remove. It makes a big difference to the finish of the model once it's painted. Again, take your time with it and do not catch the machine surfaces whatever you do. The surface finish of castings varies tremendously. Some are good and some are not so good. If they're really bad, I would say you should be doing this before you start the machining process. Be careful not to remove too much metal, you just need to get rid of the moulding lines. These are Stuart Victoria and I believe Beam Engine and James Coombs cylinders. And the good thing about them is that they have the ports and the steamways cored in already, which saves drilling from the end of the cylinder to the ports, which is not the best job in the world. It still makes me nervous after all these years. But sometimes you can get a casting where the steamways are completely full of black sand. So it's important to remove this so you don't blunt the boring tool as it travels down the cylinder. But mainly because you can build up the engine and make it so that when you put the steam into the engine or the compressed air, it doesn't work because the ports are full of sand. Just use a paper clip and poke it up the ports and you can get rid of all the sand. And that's it for this episode. Thanks for watching and I hope you found it useful.